Managing and querying the data created by Daml application requires understanding the concept of active contract set, data pruning, and using an operational data store. In this lesson, we will learn about these concepts which are critical for designing a high-performing Daml application. There are two important concepts to understand about the data created by Daml applications. First, what is stored, and second, where it is stored. As the contracts in Daml are immutable, they are not deleted or updated. If there is any change in a contract, the old contract is archived and a new one is created. Therefore, a ledger at any point in time has an active contract set, or ACS, which is a set of all active contracts at that time. The ledger also stores the history of transactions that led to this ACS. This history is represented in the form of transaction trees. A transaction tree is a hierarchical structure in which a high-level transaction, for example, making a change to a contract, is carried out in a series of subtransactions, such as archiving old contract and creating a new contract. For example, let us say we want to create an account and deposit $20 in it. So transaction 0 creates an account contract, which becomes an active contract. Then another transaction is carried out to deposit some money in it. This has subtransactions, exercising the deposit choice on the account contract, which further has a subtransaction of archiving the old account contract and creating a new account contract with $20 in it. At the end of these transactions, we have one active contract for the bank account with $20 in it and a history of the transactions carried out before it was created. As you can see, this can lead to the ledger size reaching orders of magnitude higher than similar loads in traditional database systems, which can negatively impact the Daml application performance. To overcome this challenge, we recommend some best practices and techniques. First, when designing workflows, pay attention to the lifetime of contracts. If there are any supporting or auxiliary contracts, make sure they get archived when their purpose is done. To further control the lifetime of workflows, make them complete within a limited time frame, and add a choice to archive their contracts once the time frame has expired. This way, workflows that get stuck can always be cleaned up after a certain amount of time. And second, set up a data pruning schedule. Pruning refers to the selective removal of archived and unneeded data from participant, sequencer, and mediator nodes. Automatic pruning schedules can be created as cron jobs at the frequencies desired for each node. Pruning deletes the data, but it does not perform any database maintenance, such as table resizing. So for that, you will need to use the database system's features for further optimization and vacuuming of storage space. Pruning is an I/O-heavy operation, so it should be scheduled during maintenance windows. You will find more details about how to schedule these pruning activities in Daml documentation at docs.daml.com. Now, the next question to think about is how can we access the data stored in the Canton network? And for that, let us look at where it is stored. When a command is submitted, it is submitted to a sync domain used by the participant node hosting the submitting party. The command flows through the sequencers and mediators to reach participants hosting the affected parties. The contracts resulting from this command are stored in the private contract stores of all the participant nodes where the involved parties are hosted. They are also stored in an encrypted form on the sequencer backends for delivery to involved participant nodes. It is important to note that the applications use the data in participant nodes and not on the sequencer backend, as the sequencer backend is a relatively temporary storage. To access this data stored in the private contract store, web UIs use the Ledger API, including JSON API for getting the current state of the ledger in bulk, streaming events and state changes, and pointwise queries like fetching contracts by key or ID. They can query over the ACS, for example, to get all active contracts where field X is set to value Y. We can also query the historical data, which can both include actually showing the history directly, for example, the transaction history in a wallet, as well as aggregates, for example, how much did I spend in the last month. However, submitting complex queries directly to the Ledger API can adversely affect the Daml application performance, and the reasons are, first, the JSON API used by Daml applications to access the ledger is not designed for high-performance complex queries, and second, it cannot access historical data and full transaction trees. The recommended approach is to use an operational data store, or ODS. Having an independent ODS that mirrors the ledger will allow efficient querying without negatively impacting the Daml application's performance. One option for implementing an ODS is to use the Participant Query Store, or PQS, which is part of the Daml SDK. PQS ingests the contracts and transactions into a Postgres database. It thus allows the backend to use JDBC and the rich querying capabilities of SQL. Query execution can then be accelerated using standard tools like creating indices. You can find more detailed guidance on how to set up an ODS in docs.daml.com. Let us now summarize. As the ledger data has contracts that are immutable, they are never deleted or overwritten but are archived. So the data storage at the nodes has an active contract set, along with historical data of archived contracts, which continues to grow at a fast pace. To handle this data growth effectively, you should pay attention to lifetime of contracts when designing them, and also use the data pruning feature through which you can selectively remove archived or unneeded contracts from the storage. Daml applications create data in the form of contracts that are stored in the private contract stores of participant nodes, where the parties involved in a transaction are hosted. This data is also stored in the sequencer backend in the sync domain. Finally, to query the data stored in the ledger, it is recommended that you set up an operational data store and use that as the source for performing complex queries instead of querying the ledger directly, as it may impact the Daml application's performance. Daml offers Participant Query Store, or PQS, as an ODS that can be set up in a participant node.